Okay, so let's look at the last part of section 6.2. Okay, I'm going to just kind of list out the goals, kind of what we're going to try to figure out here first. So we want to know how to figure out trig functions, not just for the angles we learned yesterday, the 0, 90, 180, 270, but we also want to be able to figure it out for the angles 30, 60, and 45. If you converted all those to degrees, that's what they would be in that order. 30, 60, 45. Or any multiples of those angles. So what's multiples of 30? Well, like 30, 60, 90, 120, 150, things like that. Multiples of 45, 45, 90, 135, 180, 225. Okay, and there's some overlap there too. Sometimes a number is a multiple of both 30 and 45, like 90. Okay, so that's the first thing you're going to look at. And then the second thing, I kind of showed you a little bit of a preview of it by showing you that sine over cosine equals tangent. Okay. What I showed you there, that was called a trig identity. Okay, and we're going to spend very, very little time on it. Not much. All right, so just quick reminder about two special triangles from geometry. There's the 45, 45, 90 right triangle, and there's also the 30, 60, 90. So you might be like, well, why do we need that? Well, if that's 0 and that's 90, 45 is exactly halfway between. So I've marked 45, and I drew an angle. Here would be your initial side. There's your terminal side. It's a 45-degree angle. Well, the goal, anytime you're doing unit circle trig, is not to have the angle, but you need the what for the angle? You need the coordinate. So our goal is to figure out the coordinate for a 45-degree angle. Well, if you draw in that dotted line, you just created a triangle, a right triangle, and it's a 45, 45, 90 right triangle. Okay, and in a 45, 45, 90 right triangle, rather than going through the whole proof, which it's not too bad, but I'll save a little time. Actually, you tell me first. How long is this side?
1.
Why?
It's the radius of the circle.
It's the radius of the circle. Okay, remember, we're working on a unit circle. So the radius is 1. And in an isosceles triangle, the other two sides, what's the relationship between them? They're the same. And what it works out to be is both of them are the square root of 2 over 2. If you want to check it, just do the Pythagorean Theorem on it. Type that into your calculator and square it. Type that into your calculator and square it. Add them up and take the square root, and you will get 1. Okay, it works. So, this point right there is like this point right there. So, in order to go from the origin to 45 degrees, first you travel to the right. And how much do you travel to the right? Well, the length of the base of the triangle, which is how much? So we're going to travel to the right, square root of 2 over 2. And then from that point, you're going to travel up to get to your coordinate. So this is that. So you travel up the height of the triangle. And what's the height of the triangle? It's also going to be square root of 2 over 2. So in for a 45-degree angle, the x-coordinate is square root 2 over 2. And so is the y-coordinate. And that never changes. A 45-degree angle always has those coordinates. Any question on that? Okay. It's the 45, 45, 90. And let's look at the 30 and the 60. I guess you could say I'll make it a different color. Okay, the red triangle, that's the 30-degree angle. The black triangle is the 60. I just drew them both on the same picture. What's the difference between the red triangle and the black triangle? If you were to like cut them out of paper and then line them up.
The height.
Would they have different heights?
No, they're actually the same.
They're the same thing. The red triangle and the black triangle are exactly the same thing, except one of them standing up on the short side, the other one's laying down on the long side. But they're the same triangle. All right. So regardless, if you look at the black one or the red one, how long is the hypotenuse?
1.
Yeah, it's 1 in the triangle. Okay. And again, from geometry, the short side, does anybody remember the connection between the short side and the hypotenuse? In a 30, 60, 90, the short side is always half the hypotenuse. Always. So if the hypotenuse was 10, the short side would be 5 in a 30, 60, 90. And now once you have two sides, what theorem could you use to get the third side? You could do the Pythagorean Theorem. I'm just going to tell you what the answer comes out to if you do it. It will come out to the square root of 3 over 2. Right. So in a 30, 60, 90, we know that the short side is always 1/2. We know that the long side is always root 3 over 2. Okay, so let's look at our red triangle. Here's the long side. How long did we just say the long side is? Square root of 3 over 2. And how about the short side? 1/2. So there's your coordinates for 30 degrees. Go right, square root of 3 over 2. Go up, 1/2. Now, since the 30 and the 60-degree angle use the same triangle, except it's standing up on the short side, what do you think is going to happen to the coordinate? They flip. Now, for 30, 60, 90, there's your short side. There's your long side. So now the short side is 1/2. Long side, root 3 over 2. So to do everything we're going to do with unit circle trig, from today, all you have to remember is the numbers root 2 over 2, root 3 over 2, and 1/2. That's a 3. All right, and that's it. So 30 is root 3 over 2. Make sure you copy that. I fixed that. Root 3 over 2, 1/2. The other one is 1/2 root 3 over 2. And mirror imaging that into another quadrant is really super easy. The side lengths don't change. All that happens is you put a negative in front of one of the numbers. Or if you put it down here, it would be in front of both. Okay, but we're going to practice just a little bit in the first quadrant, and then we'll worry about the other quadrants. Okay, so I want to find the 6 trig functions of 45 degrees. Okay. They gave me an angle. What's the first thing I have to do unit circle trig? if they give me an angle. I have to find the coordinate. If you can't, you're stuck. Got to find the coordinate. Now, rather than go through the whole picture again, we should just write it down or memorize it. What's my coordinate for 45 degrees? Yep. Root 2 over 2, comma, root 2 over 2. Does that coordinate look familiar? We did it in homework. So now, the rest of this problem we just did last night in the homework. The only thing is you didn't know that that was the coordinate for 45. Now you do. Okay, so we'll go through real quick again all the trig functions. Okay, what would my sine be? Yeah, a y value. Cosine? Yep, this time the x value. The tangent? 1. And we know when we flip it, we're going to get 1, so that's a quick one. Anybody remember what we got when we flipped root 2 over 2? So we start with this, but then we had to fix it.
Just the square root of 2.
It ends up as the square root of 2. Thank you. And then if that ends up as the square root of 2, so does that one because the sine and the cosine were the same. Again, on the test, that would be 6 separate questions. I'll ask you for one trig function per problem. Any questions on that?
Yes, what do you mean?
So, like,
For 6.
Yeah, I wouldn't ask you for all 6 like this in one problem.
Oh.
This would be 6 separate questions on the test.
What's different numbers?
Yeah, I probably won't give you a coordinate and say do the same coordinate 6 times. I'll maybe give you a coordinate like this, and I'll say just tell me the tangent. And then I'll give you a different coordinate and say just tell me the sine. Okay. Let's look at 30. Okay, again, they're telling me the angle. First thing I need to figure out is the coordinate. Now, with the 30 and the 60, I know it's a half and a root 3 over 2, but I don't remember which way. Is it 1/2?
3 over 2.
And if you forget which way it is, just make a sketch. Put your 30-degree angle right there. Draw a triangle. And you should be able to very easily tell where the long side is. The long side is the bottom. The long side is x. So x is root 3 over 2. The short side is 1/2. Okay, it doesn't even have to be drawn perfect. Just put 30 in a reasonable spot, and you should be able to figure out the long side, short side. Okay. So what's the sine of 30 degrees? 1/2. Cosine? Square root of 3 over 2. And the tangent is when you basically just put a division line right there. The tangent is y divided by x. So let's do that out. Y over x. Now, when you divide fractions with the same denominator, what happens to the denominator?
Disappears.
It cancels. You can flip and multiply by the reciprocal. It's the same thing. You have the same denominator, it cancels out. So that's good, but we still have a problem. We have 1 divided by square root 3. What do we multiply by to fix it?
Square.
Keep this for now. That's going to come in handy in a second. But for the final answer on tangent, you do need to fix it. And you get square root of 3 over 3. Now, once we get the 3 on the left, what do we do with all of them to get the 3 on the right?
Wait, why would you get square root of 3 over 3?
So you got 1 times the square root of 3 in the top, and then in the bottom, square root of 3 times square root of 3 is square root of 9, which is 3. Okay. So now, what am I going to do with those to get the next 3? Just flip them. Just the reciprocals. That one's easy. get 2. Now, this one you're going to get 2 over the square root of 3, but can anyone tell me what you'd get once you fix that? 2 square root 3 over 3. Yep. And now the cotangent, I said to hang on to something because it would come in handy. What I put a dotted circle around, that is equal to that. So you could flip either the final answer or the one I have the dotted circle around. Yeah, I would flip the dotted circle because if you flip it, the root goes to the top and you're done. If you take the final answer we got for tangent and flip it, now you're putting the root back in the bottom and you're going to go through the whole thing again to fix it. But those are the 6 trig functions of 30. Any questions on that? All right, this one, they're asking us to find the 6 trig functions of pi over 3. If we're not sure what that is, we can convert it. So it's a little easier to think about. Okay, how much is pi again? Pi is 180. So what's 180 divided by 3? 60. So in other words, I want the coordinates for a 60-degree angle. Well, we just did the coordinates for a 30. Root 3 over 2, 1/2. What happens for the 60? Switches. 1/2 root 3 over 2. So you're going to get all the same answers again, except everywhere there was an x, you're going to have a y. And wherever there was a y, now you have an x. They all switch. So what would my sine be? Now that's my root 3 over 2. My cosine? Yep, 1/2. And the tangent is y divided by x. So just pretend like you're dividing those two numbers. If you divide them, they have the same denominator, so what happens to it? Cancels out, and you have square root of 3 divided by 1, which is square root of 3. Secant, that's a quick one. What's the secant? 2. Flip that. This one is going to be 2 over the square root of 3 when you flip it, but we just fixed it on the last problem. 2 root 3 over 3. And now for cotangent, we don't have a fraction to flip, but what could you do to make this a fraction? Put it over 1, and now flip it. 1 over the square root of 3. And what would I multiply top and bottom by? Square root of 3. Square root of 3. And this is exactly the same question someone asked me about earlier. Okay, so just to compare them, if you look at 30 and you look at 60, all the answers are the same, except they switch places. Okay? So that's the 30 and the 60. Okay, let's look at 135. Are we in quadrant 1 anymore? No. Quadrant 1 ends at 90 degrees. So we're beyond quadrant 1. We're in quadrant 2. So what we're going to be looking at here is a mirror image of one of our triangles. The numbers aren't going to change, but one of the numbers might become negative. Do you think, is 135 a multiple of 30? And if it is, this is going to be a 30, 60, 90 triangle. Or is it a multiple of 45? It's a multiple of 45. So here's your circle. 135 is right there. You can check it, but it's exactly halfway between 90 and 180. It's the average of them. Now if I draw a triangle, just to show you why it's a 45-45. What do you have to add to 90 to get to 135? You add 45. So to go from 90 to 135, this part is 45, which means how much is the part on the inside? It's also 45, because together the quadrant is a 90. So it's kind of hard to write it in, but it's 45, 45, 90, right triangle. But now it's mirror imaged into quadrant 2. So we got to keep that in mind. What's the length of each side on the 45, 45, 90? Yeah, they're both square root of 2 over 2. That doesn't change yet.
Wouldn't the bottom one be negative square root of 2 over 2?
But now when you write the coordinate, because it's going left, you have to write that as a negative. So we went left. And what about the y? Should that be positive or negative?
Positive.
Positive, because we went up. If we were in quadrant 3, we would go down. So working with coordinates or working with angles in other quadrants, all that it involves is putting a negative in front of x, in front of y, or both. Everything else is the same. So now for 135, what would my sine be? It's the y value. And now you've got to be careful, because if you mix them up, you will get them wrong, because they're not the same. One's negative, one's positive. What's the cosine? And if you divide the two of them, y divided by x, what do you get? Yeah, you divide two things that are the same, except one's positive, one's negative, you get -1. Okay, and on this problem, I'm only going to find the 3. If I wanted the other ones, what would I do with them? Flip the 3 that I have to get the other 3. Any questions on 135?
We're doing the rest of the function?
No, not on this one. Okay. Let's try 7 pi over 6. Okay. What do you think you might want to do with 7 pi over 6? To make it easier to think about. Yeah, change it to degrees. So multiply by 180. Divide by pi. How many times does 6 go into 18? Or 6 into 180? 30. So you're left with 7 times 30, which is how much?
210.
210. Okay, let's make a sketch, see if we can find the coordinates. There's 180. How far past 180 do you have to go to get to 210? You go 30. So if I make a triangle out of that, to go from 180 to 210, this part is 30. So this part right there is 30. What does that mean the part at the bottom would be? 60. So this is a 30, 60, 90 right triangle. Another way you can tell is 210 is not a multiple of 45. Take 210 and divide by 45, it doesn't work. Okay. Since it's a multiple of 30, you're using the 30, 60, 90. Here's your short side. Here's your long side. In the 30, 60, 90, how long is the long side?
Square root of 3 over 2.
Yep. I'll worry later if it's negative or positive. And then
-1/2.
half. Now we're in quadrant 3, so both the x and the y are going to be negative. Negative root 3 over 2. -1/2. What's my sign? Cosine? Negative
Square root of 3 over 2.
3 over 2. And now the tangent, we're going to divide them. When I divide, what cancels out? The denominator and the negatives. So all you're left with is 1 over the square root of 3. Anyone remember what you get when you fix that? I think we did this earlier.
1 the square root of 3.
Square root of 3 over 3.
Yeah, what happens to the 1?
The 1? Well, when you multiply the top
Oh, okay, sorry.
and the bottom, it just turns into square root of 3. Okay, any questions on that? All right, so this method works fine as long as I keep giving you angles that are multiples of 30 or 45. And don't forget about the super easy ones we did yesterday. The 1, 0, 0, 1, negative 1, 0, 0, negative 1. Those are the really easy ones. Today's are harder. But if it's not one of the angles I just mentioned, and it's not a multiple of 30 or 45, we use a calculator. Okay, so we're going to take 42 degrees. We're just going to find all 6 trig functions. First of all, how would you know that this is a calculator question? It'll say it in the directions. And is 42 a multiple of 30?
No.
No. Is it a multiple of 45?
No.
No. So we cannot do it using the method I showed you. Okay, so on my calculator, first thing I need to do is make sure I'm in the right mode. What mode should I be in for this problem? Well, what are my 2 choices for the mode? Radian or degree? And which one is this? Degree. What if this was the problem? Now you're in radians. So pay attention to if the circle is there or not. Okay, so turn it on.
It's not turning on.
What's that? It's not turning on? Just bring it up here and you can try a different one. I'll look at it. Thank you. All right, so I'm in degrees. And the 3 on the left are...
Wait, how do you put it in the...
How do you change the degrees? You press mode, and then you put it on... Oh, I'm not in degrees. I thought I was. Now I'm in degrees, and it should change to degrees at the top. And now just type it in. Sine 42.669. That's it. Cosine of 42.743. And tangent of 42.900. Okay, most people do fine with those. It's very easy. Now, if you look at the calculator, is there a button on it that says
Nope.
CSC, SEC, or COT?
Nope.
No. But how did we do it before?
It's
What do
just
you,
the opposite, so you can click second and then just do the to the negative 1.
well, what did we do with this answer to get the other answer?
Flip it.
Flip it. That's what you do. Flip the answer. 1 divided by 0.669. That's how you do it.
On my calculator, it has like sine to the negative 1. Would that do it? Would that flip it to the...
No, that would be something different.
Oh, that's something different.
Yeah.
What mode should it be in?
Degrees for this problem. Secant of 42. Take the cosine and flip it. So you can either do 1 divided by 0.743 or just type it in directly. That's going to be a little more accurate. 1.346. And cotangent of 42 is when you flip the tangent. We're going to talk about that -1 thing later on, not today. Okay, so that's how you find a trig function if it's not in the calculator. Any questions on that? All right, so last thing I'm going to mention, and we're going to spend a whole week on this eventually, so we're not going to talk about very much of it right now, is what those things are called. When you flip one trig function to get the other, that's called a reciprocal identity. Okay. If you take the sine and flip it, you get the cosecant. That's the only way to calculate cosecant on the calculator. There's no CSC button. If you take the cosine and flip it, you get the secant. And if you take the tangent and flip it, that gives you the cotangent. So if you flip sine and get cosecant, what do you think you would get if you take the cosecant and flip it again?
Sine.
It would go back to what it was before. If you flip cosecant, you get sine. What if you take the secant and flip it again?
Cosine.
It goes back to cosine. And if you take the cotangent and flip it again,
Yeah.
it would go back to what it was again, tangent. So those are called reciprocal identities. And really, the top two, the middle two, and the bottom two are repeats.
Yeah.
They're the same identity, just kind of switching two things around. So reciprocal identities. Don't worry about that right now. Okay, so I didn't really define what the word identity means, but an identity is just an equation that's true for every value you can think of. So when I say to you, you can flip the sine to get the cosecant, that doesn't just work some of the time. You can do that for any single number you could possibly think of. So if you said to me, well, could you do it with 57? Yes. If you take the sine of 57 and flip it, you get the cosecant. Could you do it with 66.2? Yep. It always works. It's true for any value you can think of.
What about negative numbers?
Yep. All values.
Fractions?
Yep. All values. Okay, so an identity is not an equation that's true some of the time. It's an equation that's true all of the time. Okay, so I just gave you all those identities. Okay, those are called the reciprocal. Okay, I'm going to give you two more, well, actually, and then three more. But the last three, I'm just giving them to you right now so you have all these on the same page in your notes. You don't have to know the last three that I'm going to give you for the test. But I just want you to have them all on the same page in your notes.
Can you go up a little bit so we can recopy that top one?
So the top ones, those are the ones I gave you on the other page. This one, we already pointed it out earlier. Remember when we were looking at it, we said sine divided by cosine gives you tangent?
Yeah.
I did that before we even started the lesson. That's called a tangent identity. And if you flip it, well, what happens when you flip tangent? You get cotangent. So if you flip it and make it cosine over sine, you get cotangent. Okay, so for the test, that's what you need to know above that red line. Okay, the last group of identities that I'm giving you, I'm not going to explain them right now. I just want you to have a page in your notes you can flip back to, and everything is on the same page. Okay, so for the Pythagorean ones, just write those down, but we're not going to do anything with them right now. So the last thing I'll do is I'll show you a kind of problem that would be on the test with these identities.
Are those 1 plus tangent?
That says 1 plus tangent squared. Yep. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. Again, for now, just copy them down. We're not going to talk about those. Okay. So does everybody have those 3 groups of identities? Reciprocal, tangent, cotangent, and Pythagorean.
I with the top ones.
Yep. Even if you don't copy the Pythagorean now, I'll put them up again when we study them later on. Okay, let me show you the kind of problem you'd have that uses these identities. Okay. It would be a problem like that. It says simplify. And the way you simplify it is you look back in your notes and you look for cosecant and you find another way to write it. Okay? Usually with sines and cosines. So if we look back for cosecant, how can you rewrite cosecant? Cosecant is 1 divided by sine. So let's change that. 1 divided by sine. What about tangent? Let's look for a way to write that with sine and cosine. How can you write tangent?
Over 1 over cotangent.
Okay, 1 over cotangent is another way to do it, but we're going to try to do it with sines and cosines. So do you see a way to rewrite tangent just using sines and cosines?
Is it the one sine? So it's that one.
Tangent is sine divided by cosine. And the goal when you do this is hopefully something cancels out. If I multiply those together, does anything cancel out? The sine. It's kind of like multiplying 1/3 times 3/5. Well, if you have the same thing in the top and the bottom, it cancels out. So what are you left with? All you're left with is 1 with a cosine at the bottom. Look back one more time. 1 with a cosine in the bottom is equal to what? Secant. 1 with cosine in the bottom is secant.
Oh yeah.
Okay, so the point with something like this is you start out with something that maybe has multiple trig functions, and when you're done, it should look simple. That's the goal. Okay. If you want another one to try, that would be a good one to practice for the test. You could try example 8 sometime on your own. It's going to be very, very similar to the one we just did. In fact, you know what? Do example 8 instead of this one as the homework. Okay, so the homework tonight's on 335. It's mostly the unit circle and finding the coordinate, but the last problem is to simplify the identity. Secant times cosine. Okay, so we'll look at that tomorrow before the test, and then we'll have the test. Okay, also, remember that progress report's closed tomorrow.
Oh no!
I know. So I will be updating your grades online with your homework tomorrow afternoon.
Wish I knew that on Monday.